Students, we will be learning the algorithm for finding the longest common subsequence, or LCS between two strings. This is a dynamic programming algorithm, and before going into the algorithm itself, let's figure out what LCS actually means. So let's say we have two strings, one is A, B, C, D, E, and the other one is A, X, C, D, Y, E, just two random strings. Now what is the common sequence that is the longest between these two strings? In this case it's A, so it's A, C, D, and E. This is the sequence of characters that is common between the two strings and is the longest. So for instance, if you notice here, the sequence of characters does not mean that the characters have to be consecutive or side by side. For instance, between A and C there are other characters, or between here there are other characters between A and C, or between even D and E. What it means, what subsequence really means is that the sequence of the characters should be in the same order in both the strings. For instance, in this string, A appears before C, then C appears before D, and D appears before E. In this case, the same is true. A appears before C, C appears before D, and D appears before E. Now pause the screen here and tell me if the following A, D, C is a subsequence, is a common subsequence between these two. So you should be able to figure out now that it is not, right? Because neither of these strings has D appearing before C. For both of the cases, D appears after C. So now let's say if we consider this, so now let's say this string looks like this and this string looks like this. So ADC is a sequence of character here, but it is not in this. That's why it's not a common sequence here. Okay, so if we are considering two strings, there might be multiple common subsequences between the two strings. For instance, let's consider strings Y and X here. So ABCE and ABEC, there are actually two longest common sequences between these two strings. One is ABC, because in both cases A appears before B and B appears before C, and the other one is ABE. So there can be multiple longest common subsequences between two strings, but in our case, in our algorithm, we will be only finding one of the common longest sequences. Now I hope that the idea of the longest common subsequence is clear to you guys. If it's not, then please pause, or rewind, go back and make sure that it's very clear. If you don't understand it from my video, then just look it up in Google. You'll have many other videos. You can look it up in our playlist that we shared with you, and you can just read it up somewhere. But before we move forward, make sure that you understand what it means when we say longest common subsequence. Okay, so now assuming that it is clear to you, let's dive into the algorithm and see how we should find the longest common subsequence between two strings. Let's say we have two strings, X and Y. One of them is cake and the other one is crane. Now we will need a two-dimensional array or matrix. The number of columns in the matrix would be equal to the length the length of one of the strings plus one additional column, and the number of rows would be equal to the length of the other string plus one additional row. For instance, in this case, I have taken the columns to represent the string y. So y has 5 characters, so the number of columns is 5 plus 1, and the rows will represent the string x, and x has 4 characters, so the number of rows is 4 plus another one additional. Okay, so it doesn't really matter if I represent x in the columns or the rows, or y in the columns or the rows. It really doesn't matter. You can represent x in the column and y in the rows as well. Okay, so let's begin. To make this easier during our simulation, what I would do is I will write the corresponding characters here. So the characters of y are C, R, A, N, E. So this might take a little bit time because I'm writing with my mouse. It's difficult, so bear with me. So the other one is C, A, K, E. So all our characters are represented in the 2D matrix. Now what we would do is we will store two different information in the matrix. One is the cost or the length of the subsequence, and the other is the direction. Now what it means by direction will become clear as we go through the simulation, but just to give you an idea, we will be considering 3 different directions. One is diagonal direction, diagonal. So taking a lot of time, sorry about that. Okay, the other one is up. Okay, so up would be represented by the up arrow, and the other one would be left. Left would be represented by the left arrow. So in a lot of simulations online, you might see that the arrowhead is in the opposite direction. It might be in this direction, it might be here or here. It doesn't matter, it's all the same. Anyways, so 3 directions. One is diagonal, one is up, and one is left, and we will be representing them with these arrows. So at first what we have to do, we have to make the index 0. We have to store 0 in index 0. So for the column, in all the 0, in the 0th column, we will save 0 like so, and then in the 0th row we will save 0 like this. Okay. So now we will consider this cell where the index number, the column number is 1 and the row number is 1. So we will compare the first character of y with the first character of x, and we will see if so first character of y with first character of x, and we will see if these two are same or they are not same. So if the characters are the same characters or they are different characters. So obviously C and C are the same characters. So if they are the same characters, what we have to do is we have to add 1 with the diagonal value. So we are saving the value here, so we have to add 1 with the diagonal value of this cell. So here the value is 0, so 0 plus 1 is 1, so we have to save 1 here. And since we kind of used the diagonal value, that's why we have to save the diagonal direction here. Okay, so if 2 characters match, we will add 1 to the diagonal value. Okay, and we will save the direction as diagonal. Now we will match the first character of x with the second character of y, so which is C and R. So do they match? Obviously no. So if they don't match, we will consider, so we are saving the value here, so we will consider 2 values. One is the up value and the other is the left value. So we will compare these 2 values, the up value and the left value, and we will save the one that is higher. So between 0, the up value is 0 and the left value is 1, right? So between the two, 1 is obviously larger. That's why we will save 1 here, and because we used the left side value here, that's why we will use the left arrow. Now we will compare C with A. Do they match? No. So we have to compare the up value with the left value. So the up value is 0 and the left value is 1, which is greater, obviously the left value, so we will copy it here. So again, do C and N match? No. So up and left, the higher value is left, so we save left here. Again, do C and E match? No. So we will compare up and left, and we will save the one that is larger, which is left. Now we will be comparing the second character of X with all characters of Y, one by one. So A and C, they don't match, so we have to compare the up value and the left value. Which one is higher? In this case, it's the up value, so we use the up value and the direction would be up. Now between A and R, they don't match. Now we compare the up value and the left value. Now both are equal. Before, what we were doing, we were saving the one that is larger, but now the upper value and the left value are equal. So what do we do? So we have to take any one of these values, but we have to remember the side that we choose, the direction that we choose, because in the next cases, if we face a similar situation where the up value and the left value are equal, in the next case we have to choose the one, we have to stick to the decision that we make right now. So let's say I decide to if they are equal, then I will be taking the up value. So so I'm taking the up value, my direction is this. Again, A and A, they do match. So if they do match, what do I have to do? I have to take the diagonal value and add 1 to it. So 1 plus 1 is 2, and my direction would be diagonal. So now A and N don't match, so I have to consider the up value and the left value and write the one that is higher. So 2 is larger and it's from the left. Similarly, A and E don't match, so I compare the up and the left value and write the one that is larger. So please pause the video here and make sure that you understand the whole thing, and in fact try to fill the remaining 8 cells before you proceed further. So if you have already done that, so I'll just quickly solve it for you. K actually doesn't match with any of these characters, so I'll never actually take the diagonal value, so I have to always compare the up and the left value. So K does not match C, so I compare up and left. Up is higher. Here K and R don't match, so I compare up and left, both are equal. So before I said when we found equal up and left values, then we were taking the value from up, and we have to maintain that direction. So for the first time we can choose any direction, but for the other times we have to maintain that direction. K and A don't match, so now we have to compare. The up value is higher. K and N don't match, the up and left are equal, so we were taking the up value. And again, K and E don't match, so the up and left value are equal, we were taking the up value. Now E and C, they don't match, so up and left, we compare between the two, and up is higher. We compare. R and E don't match, we compare up and left. Up is both are equal, so we're taking up value. E and A don't match, we compare up and left. Up is higher, so we take up. We compare N and E, they don't match, so we compare up and left value. They are equal. If they're equal, we are taking up. and then E and E do match, so we take the diagonal value, we add 1 to it, and then save here. So diagonal value is 2, we add 3 1 and it becomes 3, and we save the diagonal arrow. Okay, so now we are done with the simulation. We wanted to find two things from this. One is the length of the longest common subsequence, which is the LCS, and the LCS itself, which means what are the characters in the sequence. So the length is always in the last cell, which is the last cell, last corner in the bottom right corner. So the length of the LCS is 3. So length is 3. Length taking a lot of time. Okay, length is equals to 3, which we got from here, right? And now we have to find what's the LCS itself. So to find the LCS, we have to backtrack. So what we are going to do, we will start from this last index and we will just follow the arrow. If we find a diagonal arrow, so we found a diagonal arrow here. So if we find a diagonal arrow, we will save this character. So this is a diagonal arrow, which means we took this character. So in both the column and the row, it's the same character, right? E. So we will save E. So E is saved, and then we will follow the arrow. So the arrow says go diagonal, so we go diagonal, we come here, right? So then it says go up, so we go up, we come here. Then it says go left, so we go left and we come here. Now this is another diagonal, so we have to take this character, which is A. So we write A. So notice that I am writing on the left side. This is because we are starting from the last character going to the first character. That's why I've started writing. I'm always appending on the left of the sequence. So now again we have to go diagonal, so I go diagonal and then I come here. Then we have to go left, so I go left and I come here. So this one is another diagonal, so I have to take this character, which is C. Now I have to go diagonal again, so I come here. So if I reach the 0th index, whether in the row or the column, then I'm actually done simulating. So this is basically my LCS CAE. This is the longest common sequence that is common between the two strings X and Y. So I hope the explanation is clear to you guys. If it's not, then pause and try to go back and look at it again so that it's clear. If my explanation isn't clear, then you can go through other simulations or other videos. That is fine. You can contact me or the student tutor for an explanation. So we will soon be having our live Q&A session where you can actually ask questions if you haven't understood it. Before finishing, so this is the simulation, so let's just quickly go through the algorithm. Where is it? So it's not here. Quickly go through the algorithm. So this is the algorithm to find the length of the LCS. So here we have two strings X and Y. M is the length of X and N is the length of Y, and we will have two-dimensional arrays. One is called C and the other one is B, and the dimension of the array, both the array have the same number of columns and same number of lengths, like this. Like one of the number of columns would be the length of one of the string plus one additional column, and the number of rows would be the length of the other string plus one additional column. And Why we are maintaining two different arrays is because we have to save the direction and the cost, and when you are implementing you will need two arrays. You cannot do it in one array, but when you are doing the simulation you can do it in one single error matrix. So let's go back here. So now we are making the zeroth index. This is the zeroth so this is the zeroth column. We're making it 0, and then we'll make the 0th row 0, right? So we did this initially. We made this column and this row we saved 0. After that we are running to a nested loop. I will go from 1 to the length of x, and j will go from 1 to the length of n, and I'm comparing each character of x with all characters of y in each loop. So I'm checking if x, the ith position character of x, is it equal to the jth character of y. If they are equal, then I'm taking the diagonal value. To access the diagonal value of any cell, I have to do I minus minus and j minus minus. So I'm accessing the diagonal value, and I'm adding 1 to it, and I'm saving the direction as NW. NW means northwest or diagonal, so you can save any numerical value such as 1, 2, 3 for each direction. You can save any characters. In this case they are saving strings, so NW represents diagonal, N represents which means north, it represents up, and W is left, and it means west. So if the characters match, I'm taking the diagonal value plus 1, and I'm saving the direction as NW. So B is the direction array, and C is the cost array. If they don't match, if the characters don't match, I'm checking if the upper value is greater than equal to the left value. If it is true, then I am taking the upper value and I'm saving the direction as north or up. And if this isn't true, it means that the left value is actually greater than the upper value. In this case, I'm taking the left value and I'm saving the direction as W or west or left. So this is how I'm doing. I'm finding the length of the LCS, and this is kind of after the simulation for these two strings. This would be the value, and this is kind of a pseudocode for kind of backtracking and finding the sequence itself. So I hope LCS is clear to you. We will be meeting later on and kind of discussing it if you have any questions, or you can also ask any questions on the forum. Thank you, and talk to you next time.